Hello everyone, so in this problem here we go from a carboxylic acid into a cyclic acetal. We're asked to provide an efficient synthesis for making this reaction possible. So to start, we'll think a little bit retrosynthetically, and then we'll think in the forwards direction to achieve this reaction. So I know that if I want to make a cyclic acetal, and let me just draw out our starting material. I know that acetals can be made by using, and this specific cyclic acetal is made from a ketone. Right, because if you recall, if we use just the alcohol in an unaqueous environment, then it will form this here. Right, and we need to use an acid catalyst too, H2SO4, HCl. Either one works. I prefer H2SO4. So this is about where the retrosynthesis ends, because the next steps can be kind of tricky, but you need to just think forwards. So we'll think in the synthesis direction. How can we make a ketone from a carboxylic acid? But also notice where this OH is, we put on a 2-carbon ethyl group, so we also need to equate for that. So I know on carboxylic acid derivatives, if I add a, say, specifically you don't want to add a Grignard because it will react twice and you'll get a tertiary alcohol. But if we react it once with, say, a Gilman reagent, then it will only go one time and we'll keep a ketone on there. So that's how we made this, but you can't do a Gilman reagent with our hydroxide here, because the polarized bond simply will just rip off a proton, destroy the Gilman reagent, and you'll just get a carboxylate, and that's not what we want. So let's think in the forward direction now. So we have our carboxylic acid, and I know that the Gilman is going to be tempted by that tasty little hydrogen there. So let's convert it to a non-protic carboxylic acid derivative. So if we use, say, for example, an acyl halide, the most reactive, this will not only improve the yield, but help that Gilman really react. So we know that SOCl2 is going to make the acyl chloride. So we have that there. Okay, now we need to bridge the gap. We just need to kick off this chlorine and replace it with an ethyl. We do that with that Gilman reagent. So we use an ethyl Gilman, or an ethyl or lithium diethyl cuprate is what we would call that in fancy terms. So this bond's pretty polarized. It makes it just able to attack the carbonyl center, kick up electrons. The electrons come back down and kick off the chlorine. Right, so then we get this here. So the overall synthesis would go, so you have your carboxylic acid, you use SOCl2 to get the acyl halide, then we use ethyl or lithium diethyl cuprate to form a ketone with the ethyl group attached, and then we use acetal, cyclic acetal reactions to make our this is technically a protecting group, but our cyclic acetal. Hope you guys enjoyed. If you did, please drop a like, subscribe, comment if you have any questions, and have a wonderful day. Yay.